So hello everyone. Like the first way, or the you can say the traditional way of solving this problem is that we can first take the distance of any of the particle. Like I have taken here particle d and its distance from the center. So if I say the distance is r, so we have a formula for a regular polygon, and the distance of any of its vertex from the center is L by 2 sine 180 by n, where n is the number of sides in the polygon. So r is equal to L by 2 sine 36 here in this case. And now if I consider the velocity along OD, so velocity along OD is v cos 54. So v cos 54 into t is equal to L by 2 sine 36. So the t comes here is t is equal to L by 2 sine 36 cos 54 into v, and we know that cos 54 is sine 90 minus 54, which is sine 36. So time is L by 2v into sine square 36, and we know the sine 36 value, which is under root 10 minus 2 root 5. So after putting this value, we get time as 4L divided by v into 5 minus root 5. And a more clear visualization of this problem is that, like, the particle or the velocity of each particle on the each vertex of the polygon has velocity directed towards its neighbor particle. So at every instant they all will be creating a new polygon, and eventually at the time t they will collide at the center of the polygon, which is the pentagon here. And the uh, and the other way to solve this problem is from relative velocity concept. So I can take any two particles, and I have taken here d and c for the convenience. So I have taken velocity of c with respect to d, which is velocity of c minus velocity of d, and velocity of c with respect to d. So we have to give the d velocity to both the particles. So along the line CD, the velocity of c with respect to d is v plus v cos 108 degree, which is nothing but v minus v sine 18 degree. So v minus v sine 18 into t is equal to L. So t is equal to L divided by v into 1 minus sine 18. So sine 18 is root 5 minus 1 by 4. So time comes is L divided by v into 5 minus root 5 by 4, which is 4L by v into 5 minus root 5, which is the same. So the three particles will be meeting at this time. And now comes the most amazing part of the question, that is the equation of trajectory. So if we find, or we rather try to find, equation of trajectory with the help of polar coordinate system, so it would be much easier. So in a polar coordinate system, we are taking a unit vector, that is r cap, along the radius, and a unit vector theta cap that is perpendicular to the radius. So it is clear that if we differentiate r, that is the position vector, so we will be getting something like this, and we'll get the velocity vector, which is dr by dt in r cap plus r d theta by dt theta cap. So it gives the components of the velocity vector, or velocity along the radius and perpendicular to the radius. So if we consider OD as the radius of the pentagon, so the velocity along that radius will be dr by dt, which is v cos 54, and perpendicular to the radius, which is r d theta by dt, which is v sin 54. So we have got two equations, and we can now compare we can try to bring r as in terms of theta. So 1 by r, after dividing 1 by r, dr by d theta is cot 54. So after taking d theta to that side and integrating on both the sides, so 1 by r dr is equal to cot 54 d theta. So we have integrated, and we get something log of r is equal to cot 54 into theta. So we get the like the radius as the function of theta, as r of theta is equal to e into cot 54 into e to the power cot 54 into theta. So we have find out the equation of trajectory. So right now, the equation or the equation of trajectory which we have or which we had got was r is equal to, or r as a function of theta is equal to e to the power cot 54 theta. So it is clear that it is the equation of a logarithmic spiral. So after, like, we can take on the trajectory an infinitesimal element dl, and we can, after taking r plus dr as that change in the radius, and after like bringing or making a triangle, as you can see that dl with hypotenuse dl, perpendicular dr, and the base r d theta. So r d theta has come, like we know that theta is equal to l by r, so l is equal to r theta. So here theta is nothing but d theta, and the r is the r itself. We are not considering r plus dr because it is a very small or minimal change in r. So dl square, like we get one relation from the Pythagoras theorem. Dl square is equal to dr square plus r square into d theta whole square. So dl we get as under root of dr square plus r square d theta square. So we need to bring, in order to integrate on both the sides, that we need to integrate with respect to something. So we are, as r is a function of theta, so we are differentiating it with respect to d theta. So after dividing it and multiplying it, we get a dl is equal to under root of dr by d theta whole square, which is nothing but the differential or derivative of r, and plus r square d theta. So on integrating on both the sides, we get something, and l is equal to under root of e to the power cot 54 theta into cot square 54 theta square plus r square. Like basically the chain rule is getting applied here. So after integrating, we get l is equal to e to the power 2 theta cot 54 cot square 54 theta square plus r square to the power 3 by 2 divided by 3 by 2 into 1 by cot square 54 into theta square. So we have found out the distance covered by each particle. So thank you for watching.